actually some young people in the audience. Usually when I give a talk, and I don't give that many, but I say, old geezers again. And you know, the thing is, it's the young people that really have something at stake here. And so that's the question. You know, how do we achieve justice for young people? Because, you know, it's hard for people to recognize the issue of climate change because the effects compared to weather fluctuations, the weather fluctuations from day to day can be enormous, 10 or 20 or 30 degree fluctuations in temperature. But the reason this is a difficult problem is because of the inertia of the climate system. The ocean is 4 kilometers deep, the ice sheets are 3 kilometers thick. They don't change quickly as humans begin to apply forces to them. But that's part of the problem, because of their inertia, we've only felt part of the response to those forces. The rest is in the pipeline, but it's going to occur in the future, during the lifetime of young people, most of it. Because it turns out that our climate system is dominated by amplifying feedbacks. It didn't have to be that way, but that's the way it is. I mean, for example, as the planet gets warmer and the ice and snow begin to retreat, that exposes darker land, which absorbs more sunlight, and it amplifies the effect. And some of these, the most important of these feedback, occur over decade to century timescales. So the danger is that we're going to hand young people a situation that's out of their control. And we're very close to that point. So that what we're going to have to do to avoid handing a disastrous situation to young people is reduce fossil fuel emissions rapidly. And that is technically possible. And the tragic thing is, if we don't do it, it's the fact that it actually makes economic sense. But the solution is actually not being pursued. There are three fundamental injustices involved in this problem. The one is obvious one, that today's adults are gaining the benefits of burning fossil fuels, and the benefits are huge. The way that half of the world has raised itself out of poverty is the energy that's provided by fossil fuels. But the consequences of that are going to be felt by young people. So there's an intergenerational injustice there. And then there's the north to south, because it's the United States and Europe and Japan who are burning the fossil fuels, but the biggest effects occur at low latitudes in countries where the people have done almost nothing to cause the climate change. And then there's, of course, one species threatening to cause extermination of a significant fraction of the other species on the planet. And that's a different form of injustice. So let me mention that the two issues which are irreversible. The one is obviously species exterminations, and it's a combination of various stresses that humans are placing on different species, along with shifting climate zones, which is the most threatening thing. And I like to use this insect, the monarch butterfly. The reason I started with the monarch butterfly about 10 years ago, because I wanted I don't think it's appropriate to frighten young people about climate change, because young people are more sensitive than you might think. If you tell them that, oh, there's potential disaster ahead, you know, some of them actually worry about that. So you shouldn't do that. So instead, my thought was, oh, well, we can introduce my grandchildren to nature by getting them to help me plant milkweeds, because, and I think that's good for kids, because they spend too much time just using their electronic devices rather than getting out and seeing nature. And we know that the monarch butterfly was threatened by, mainly by the herbicide Roundup, which kills all weeds, and the larvae, the caterpillars, can only survive on milkweeds. So we would plant milkweeds. I didn't realize that I might be instead introducing my grandchildren to the extinction of a species, because, and so there's this one summer, when my wife and I were younger, we could see 12 monarchs at the same time. More recently, you don't see any, or you might see one if you're lucky. But this one summer, we saw only one, and it was this broken-winged female. So I knew I could identify the butterfly because it had this broken wing. And she hung around for a few weeks, and she, well, there must have been a male also, because she produced larvae. She produced about 30 of these larvae, and that was one of her, that's a male after coming out of the chrysalis. These monarchs are, you probably all know them, but they're a remarkable butterfly where they migrate all the way from this small mountainous area in Mexico to the middle of Canada, and over 1 year, and then they hibernate in the winter on these fir trees on this mountain in Mexico, and somehow find their way back to this very small area, and they're just this flimsy little insect. But anyway, that year we were wondering, well, how many of them are going to make it back to Mexico? And I'd written an article about this monarchs, and Mexican scientists sent me this photo of one of the fir trees where the monarchs landed that winter. And this is his grandson looking up at the monarchs. And what they noticed was not only the butterflies, but the trees were not doing very well, these fir trees, because the shifting climate zones have got this region in frequent drought now, and that's one of the ways in which you get a combination of different stresses. And since we started 10 years ago, the number of butterflies has decreased dramatically, although in the last 2 years there's been some uptick in the number of monarchs making it to Mexico. Still, you know, less than, only several percent of what it was 30 years ago, but there has been some effort. And I think in the Midwest, there still are a significant number of butterflies. I just don't see any along the east coast of the U.S. But in any case, the story is still to be determined what happens with monarchs. But this is just an example of how it works with the multiple stresses that we're putting on the biological systems in combination with shifting. And perhaps a better example is coral reefs, where coral reefs are the rainforest of the ocean. There are more than 1 million species that are living associated with the coral reefs, and they are stressed by both the ocean getting warmer, which can cause the coral to expel their symbiotic algae and bleach and die, and also just the fact the ocean is getting more acid, and so animals with a carbonate skeleton tends to dissolve. And we're losing more than 1% per year of coral reefs. The other impact that is irreversible on any time scale that any humans would care about is ice sheet disintegration. It takes thousands of years for an ice sheet to build up from snowfall piling up on Greenland and Antarctica. And we're threatening to cause, what's happening is the ocean is getting warmer. And therefore the tongues of ice that come out from Greenland and Antarctica into the ocean are melting. And as those melt, then the ice streams can discharge icebergs to the ocean more rapidly. And you may get to the point where the ice sheet disintegrates. Greenland, the melting on Greenland, the red area which has summer melt, fluctuates with the weather from year to year, but there's a trend toward having more and more melt from Greenland. And that meltwater will burrow a hole in the ice sheet, goes to the base and lubricates the base of the ice sheet and speeds up the discharge of these giant icebergs. And we can now measure the net impact of that, because now we have this gravity satellite which measures the gravitational field of the Earth so precisely that you can see the changes in the mass of these ice sheets. And they are beginning to lose mass. Greenland at a rate of about, on the average, about 300 cubic kilometers of ice per year, which is still not a whole lot in terms of sea level rise, but the rate is increasing. And what we've shown in a recent paper is there are feedback effects that will cause, that will tend to amplify this effect. And in particular, the thing that has not been included in the IPCC, the Intergovernmental Panel on Climate Change Studies, is the effect of this fresh water on the ocean and on the ice sheet melting. As Greenland and Antarctica send more meltwater onto the surface of the ocean, that fresh water is much less dense than the salty ocean water, so it tends to form a lid on the ocean. Normally around Antarctica, in the winter, this circulation, the deep ocean circulation, will bring deep water, will bring the North Atlantic deep water to the surface around Antarctica, and in the dead of the Antarctic winter, it's like minus 30 degrees or something over the sea ice. But when this warm water comes up, it'll melt sea ice, and then it's about 0 degrees, and so you get a lot of heat being discharged to the atmosphere and to space. And that's a way in which the ocean loses heat. Well, what's happening now, if you put this lid of fresh water on there, it stops that sinking of the cold, salty, deep water, because it's now fresh water at the surface. And that means the heat that would normally be expelled to the atmosphere is instead melting the ice shelves. And that's why the ice shelves seem to be melting faster and faster. And what we find in our climate model is that the paper we published a month ago, we show that meltwater causes cooling southeast of Greenland and cooling around Antarctica, where this fresh water is injected. And in fact, the observations are now beginning to show that already now. This is shifted 180 degrees, but you can see it's getting cooler southeast of Greenland and around the coast of Antarctica. And the rate of sea level rise is still, it's at a rate of about 14 inches per century, which is still not, it's a nuisance, but it's not a disaster. But the rate is accelerating, and if the rate at which mass is being lost from the ice sheets has been doubling at a 10-year time scale, but the record is too short to confirm that as a good estimate for the long term. But if that's true, it would mean we would get to the meter scale sea level rise within 40 to 50 years, and multimeter soon thereafter. And if we look at the Earth's history, which is our best guide for how sensitive the system is, we see that the last time it was 2 degrees warmer than pre-industrial, which would mean 1 degree warmer than today, sea level was between 6 and 9 meters higher than it is now. That's 20 to 30 feet. Now, obviously, we can't let that happen. That would mean all coastal cities would be dysfunctional. And more than half of the large cities in the world are coastal cities. But that's a clear warning, but it's not, you can see here the blue areas where the eastern coast of the U.S., all the cities along there, and the state of Florida, and the entire country of Bangladesh, and Netherlands, for example, would be underwater. And 350 million people in China live near sea level. So we can't, we really can't let that happen. And then the other impact is an increase in climate extremes. As the planet gets warmer, that warming is smaller than weather fluctuations, but it's enough to affect the frequency of extreme events. Heat waves and droughts and fires on the one hand, but as the atmosphere is warmer, it holds more water vapor. And so the total rainfall actually increases. The times and places where you get rainfall, it tends to come in heavier events. And these are already statistically obvious, that tendency. The distribution of seasonal mean temperature anomalies is described by a bell curve. And in 50 years ago, the graphs on the left, it was an isometric bell curve, but as the planet has become warmer, the frequency of the extreme events, the ones that occurred only less than 1% of the time 50 years ago, are now occurring more like 10% of the time. This is a hemispheric average, though, and it depends on where you are. The anomalies in the United States are actually not as large as in many other places. It's about a 1 standard deviation shift in the summer, so if you're old enough and perceptive enough, you may notice a change in the frequency, but it's not standing out as much as it does in some other places. For example, in the Middle East, in the Mediterranean region, the shift is 2.5 standard deviations. So that means in the summer, and the summers are now longer. And so that means every summer is warmer than it was on average 50 years ago. And at low latitudes, the shift is 2 standard deviations in all seasons in the tropics. And things like the Mediterranean drought in recent years is, I think, related with this shift. And there are impacts of that. In the subtropics, like the Mediterranean, Middle East, and in the tropics, it's already so warm that it is affecting the ability to work outdoors. And more than half of the jobs, agricultural jobs, construction jobs, are outdoors. And people simply can't work as well. So there is a noticeable economic impact. And also, there's been a burst of research in the last 5 or 6 or 7 years on the empirical evidence for relationship between increasing temperature and conflicts and violence. It's not a physical law, but there's just this empirical evidence that interpersonal violence increases as it becomes hotter and more uncomfortable in the summers. And the intergroup and nation-to-nation violence has an even stronger correlation with increasing temperature. So an example, there is an increasing in fires. You can see statistically there are other factors that come into causing this increase in area with fires, but increasing temperature and droughts are a major factor. And likewise, the 100-year floods are occurring more often than once a century. That's in Russia, but even just a week or so ago, earlier this month, they had 24 inches of rain in one day in Houston. It was enormous. Here they're rescuing people in that flood, and here they're rescuing horses from that 2-foot rainfall. And now, one thing that we showed in our paper that we just published, you know, when Hurricane Sandy maintained hurricane strength all the way up to New York City. Normally, as the hurricane goes over colder ocean water, it loses its strength. But it kept hurricane strength all the way up to New York City. The reason it could do that is because the Atlantic Ocean along the east coast of the United States was 3 degrees Celsius, that's about 5.5 degrees Fahrenheit, warmer than normal. And at that time, people said, well, global warming in the last 50 years is 0.5 degree, so maybe 1/6 of this could be blamed on global warming. Well, actually, what we show in our paper is that this overturning Atlantic circulation is slowing down, and that not only causes it to be colder up north by Greenland, but it causes it to be warmer along the east coast of the United States. And that warming, I think, can be blamed entirely on that circulation change is an effect of the warming planet. And so the damage that was done by Hurricane Sandy, which was very extensive in New York, this is New Jersey, and this is Long Island, New York, and it, I think, is associated with climate change. So the bottom line is, the science is absolutely crystal clear. We cannot burn all the fossil fuels. I've been showing this bar graph. We've only burned the purple parts of the oil, gas, and coal. And I've been showing this for some years and not getting much reaction. But Bill McKibben wrote an article in Rolling Stone in which he said, well, these oil companies had better know that a lot of their oil, it really has to be left in the ground. You know, it's going to be stranded assets if we're going to deal with climate change. And then some people suddenly understood this fact that we can't burn all that, and yet our politicians either do not understand it, or they do not want to understand it. They don't want to take the actions that are needed, because the fundamental problem is that as long as fossil fuels appear to be the cheapest energy to the consumer, then somebody's going to keep burning them. And they're not really the cheapest. If they included their cost to society, the human health effects of air pollution and water pollution and the costs of climate change should be included in the price of the fossil fuels. And so what I argue is that we should add a rising carbon fee. You can't suddenly increase the price of fossil fuels, or it would be disruptive to the economy. But if you added a gradually rising carbon fee, and if that fee is revenue neutral, you'd collect it from the fossil fuel companies at the source. There are only a small number of domestic mines and ports of entry, so it's very easy to collect the money. then you should give the money to the public. If you give an equal amount to every legal resident, then the person who does better than average in limiting their fossil fuel use will make money. And it will be, but the main reason you want to do that is to provide the incentive for the business community and the entrepreneurs to develop products and energies that are carbon-free or low carbon. And that way, move in an economically sensible way to clean energies. And that's a transparent approach which is market-based and which stimulates innovation and would be acceptable to, I think, to conservatives as well as to liberals. It stimulates the economy, it solves the fossil fuel addiction, and it's the only approach that is viable internationally. You know, we had this agreement in Paris last December, which all the leaders clapped each other on the back and congratulated each other for saying there is a problem and we're all going to try to do better. That is the same approach that was tried in Kyoto. You know, even if some countries or some people reduce their fuel use, one effect of that is to make the fuel less dear, make it reduce its price, and somebody else will burn it. If you don't increase the price of the fossil fuel and make it honest by including its cost to society, you can't solve the problem. But you don't need, and you'll never get 190 nations to sit around a table and agree to a solution. But you don't need that. What you need is the major powers, and frankly that means the United States and China. If they agree to have a rising carbon fee, then they would put border duties on products from countries that don't have an equivalent fee. And that would be a big incentive for the other countries to have their own fee so that they could collect the money themselves rather than have us collect it at the border. And the one organization which Richard mentioned that is advocating this approach is Citizens Climate Lobby. And they're growing in size. I wish they had more young people involved in them, but they are beginning to be heard. What they do is write letters to the editor and op-eds, and they visit Congress people and senators or their staff people, and they are beginning to be heard. They're actually Bernie Sanders and Barbara Boxer they liked this idea. They introduced a bill in the Senate, but they wanted 40% of the money. And that's, I argue, won't work, because then most people will be paying more for their energy. They'll see the price at the pump going up, and they won't be getting as much money back. So most people will be losing money. And there's no conservative who would accept that. So I think it has to be, in other words, they are using part of the money to make the government bigger. And the conservatives will never accept that. But now, what Citizens Climate Lobby succeeded in doing was getting Florida representatives to form a so-called climate caucus. And they have begun to meet with, recently, with an equal number of Republicans and Democrats. So I think that's, and the Republican says there are quite a few Republicans who are a little bit afraid to say it publicly, but privately they realize that climate change is not a hoax. And so they would like to try to find a solution that's consistent with conservative principles. On the other hand, at Paris, Christiana Figueres, the leader of, in this discussion of the United Nations, said, well, many people say that we need a carbon price and then investment would be much easier. But life is more complex than that. That is hogwash, in my opinion. There's nothing simpler than a flat carbon fee across the board. And if you don't have that, you're not going to solve the problem. You can't just hope that each country will reduce its emissions. And as I mentioned, and what bothers me is that most of the countries that are saying they're going to do something, say they're going to do cap and trade. You know, that's the reason to do that. That was the approach of the Democrats. You know, when Obama was elected, he assigned to John Kerry, who was then a senator, the task of trying to get something through Congress. So what they came up with was cap and trade scheme, where you try to cap certain emissions. You actually need something that's across the board on everything. But there become enormous number of every lobbyist who could raise his arm and write a paragraph got it stapled into this cap and trade bill. So it's 3,500 pages long. And of course, it didn't. When I went to speak with Senator Kerry, and after about an hour, he said, well, yeah, what you're talking about is much simpler, and that would be better, but I cannot get one vote for that in the Senate. And the reason is that the way our government works, you've got to pay off the lobbyists, the people who provided your money in the campaign and whatever. So every lobbyist who could write gives it to his senator, and it gets stapled into the bill. And you get 3,500 pages, and then the whole thing is ineffective. If you try to do the calculations, how much would this Waxman-Markey bill, how much would it have reduced emissions? It would have been several percent. That's not, we have to get a few percent per year, several percent per year, and actually phase out fossil fuels, but they would just make a small impact. What's actually happening, emissions are going up rapidly, and especially in places like China, where it's mostly coal for electricity, and India. China is now the biggest emitter. 25% of the current emissions are from China, and the United States 15%. But it's not the current emissions that cause climate change. It's the cumulative emissions over time, because the CO2 stays in the system for millennia. So in that, the United States is responsible for more than a quarter. Europe is responsible for more than a quarter. And China for 10%, India for 3%. And if you look at it on a per capita basis, the United States is 10 times more responsible than China, and 25 times more responsible than India. And so what are we telling them? Well, Ernie Moniz is probably the best Secretary of Energy that we've had in a long time. He's done a great job. So I'm not criticizing him. But when he's asked to give a press conference with John Podesta, who was at that time Obama's climate czar, what do they talk about? Oh, we're going to cooperate with China. We're going to share information on CCS, carbon capture and storage. That's bullshit, because we did not capture, when we burned coal, we didn't capture the CO2, and it makes the electricity much more expensive. And then what are you going to do with the CO2? They're not going to do that. India is not going to do that. China's not going to do that. So it's not a solution. And I do think that, you know, if you look at the one country that did very well was Sweden. They have a lot of hydropower, which provides half of their electricity, and then they decided they're going to get the rest of it from nuclear power. And in 10 years, they built 9 nuclear power plants. So now their electricity is totally carbon-free. And they still have a carbon footprint because their vehicles still are using petrol. But once you have carbon-free electricity, you can solve the problem, because you can make liquid fuels from energy, from electricity. So what we have to do is get our electricity to be carbon-free. And I think in countries like China and India, their energy demands are so great. I see no way for them. They're now getting. Well, you can't even see they're trying very hard. China, there's at the very top of that graph, you can see there's something a little bit above the cement, which is the renewable energies. They're trying hard. Their renewable energy is greater than any other country. But I think we made a huge mistake when first Jimmy Carter and then the final blow was from Bill Clinton, who said he paid off the people who helped elect him, who were anti-nuclear people, and he's terminated research and development, or tried to terminate research and development on advanced nuclear power. Nobody would want to build more of the kind of nuclear power plants that we have now. That's 50-year-old technology. But there are many ways to make nuclear power much safer, and I think at least on the intermediate term, there may be something else out there that we'll get later this century. But right now, we've got an emergency. And India and China, we should be helping them. And we will not give them our best knowledge on nuclear power, for example. Although we burned their share of the carbon budget. We've now burned almost as much carbon as we can afford to burn. So we burned the share that the people in India and China should have their fair share. So we should be trying to work with them, not withholding information from them. As I mentioned, I don't think you should frighten young people about this issue. So, except my oldest grandchild, who's 17 years old, and she's a plaintiff on the legal suit against the federal government. But other than her, she's old enough. I didn't want to talk with my other grandchildren, but when I gave a talk at a neighbor's house, I thought that the grandchildren were in bed already, but Connor was then 8 years old. He's 8 years old in this photo. He's got the Indiana Jones hat. He was in the audience, and at the end of my talk, my wife noticed there were tears running down his face. So she ran to him and said, "Oh, Connor, don't worry. Grown-ups are working on this problem. They will solve it." Well, now, Connor is now 11 years old, and I was quite impressed by what he wrote. Because he said two things that were very perceptive. One of them was, unless we can figure out how to make a time machine that actually works, there'll be no way to fix this. That's the fundamental problem that young people are faced with. Because we're setting up a situation where you need a time machine. And the other thing is, he says, well, grown-ups are afraid of nuclear power, but we know that using fossil fuels is not safe. It is very dangerous. And by the way, the World Health Organization has said that 3.5 to 3.7 million people per year die from outdoor air pollution, mainly from fossil fuel use. And almost as many die from indoor air pollution, which is partially coal, it's partially burning dung and burning sticks for cooking and especially hits women and children. But that's 10,000 people per day are dying from fossil fuel use. So every energy source has dangers associated with it, has problems associated with it, and somehow we're not very afraid of the pollution that comes off of fossil fuel burning. It's very ugly stuff. If you look at the organic carbon and black soot that comes off, it's tiny, ugly particles which you breathe into your lungs and they get into your bloodstream. So anyway, I don't think I will talk more about nuclear power, but I will mention the lawsuit because I think this is I think is needed in order to put the pressure on the government. We brought a suit from Mary Wood and Julia Olson in Oregon. Mary Wood is the expert on the so-called trust concept, that some things are held in trust by the current generation for future generations. And we tried to use that and got as far as just below the Supreme Court, at the D.C. District Court, and there we lost the case about 3 years ago, where the judge said, you haven't shown the constitutional basis for this. The trust concept is not very clearly in the Constitution. But, so that was consistent with what I argued from the beginning, that it should be based on equal rights, equal protection of the law, and due process, that young people are being deprived of property without due process of law. And so we went back and have filed the case again. And that's what, and it's at the district court level in Oregon, and the federal government tried to get the case dismissed, and they were joined by the interveners, American Petroleum Institute, and the National Association of Manufacturers, and American Fuel and Petrochemical Association, so all the big fossil fuel industry. And the judge, it was spectacular. He really did his homework, and he really knocked down. They had the best lawyer that money can buy, but nevertheless, the judge ruled in our favor. And I think now, so it should go to trial. It still has to be certified by a different judge. Then it will go to trial, and I think we will win it. And then, no doubt, it will be appealed to the Supreme Court. But even if we win this, it's not enough. So all we're really asking is that the federal government have a plan for how it's going to assure the rights of young people by phasing out the fossil fuel emissions. But it's also necessary that they have a plan that will actually work. We can't let them do a half-baked cap-and-trade with offsets scheme. So that's why a citizens' climate lobby is so important, so that we get conservatives and liberals compromising on a solution that would actually work. And that's, I think, all that I think I will stop. So can we do Q&A? Okay, great.